Hello and good afternoon. Welcome to the latest installment of Freedom IoT's webinar series. My name is Brad Short. I'm the Director of Operations here at Freedom IoT, and I am also joined by our presenter today, Mr. Jeff Price. Jeff is the Vice President and General Manager of Freedom IoT. Today, we are going to be discussing recent advancements in the digital manufacturing environment that are being put in play by many manufacturers. Jeff is going to review and discuss the current state-of-the-art technologies and practices within digital manufacturing and the roadmap to what lies ahead in this new technological age that is available within the manufacturing landscape. The agenda for today will include a brief introduction to our company history and background, which has helped position our team as a trusted IoT and OEE partner to many manufacturing companies, both large and small. From there, we will dive deeper into digital manufacturing, how we have arrived at the current state, and highlight the benefits, the recent advancements, and the challenges the Industrial Internet of Things, IIoT, and other digital manufacturing practices have experienced from our team's vantage point today. Our goals as a partner in this space are centered around helping manufacturing teams get the most out of the equipment and processes that they employ, with the ultimate goal being true real-time and historical visibility of the manufacturing capabilities using the power of data and analytics. We often see this convergence between operational technology, the OT, with the benefits and capabilities found within the informational technologies, the IT perspectives. This starts with defining goals and understanding what data is mission critical for your operation or production, how to get started with your implementation, and then how to best scale your data visualizations to help lead your team and your business toward best-in-class manufacturing. We hope that you enjoy the following presentation. If you have any questions for our team, the Q&A tool is available within the webinar menu, and we're always available outside of the realm of this webinar as well. So we encourage our partners and customers to reach out. And now, without any further ado, I'd again like to introduce everyone to Mr. Jeff Price. Jeff, the floor is all yours, sir.
Hi, everybody. My name's Jeff, and so I appreciate you taking your time out and spending what I hope is about 30 minutes on the advancements in digital manufacturing. So first, a little bit about us. Brad talked a little bit about our company, Freedom IoT, but so we have a long-standing history in manufacturing IT solutions, and we have a long-standing history in industrial equipment, industrial automation. So this technology was first conceived in Cincinnati Millicron, which is an old machine tool brand, and of which most of all our team is from the Cincinnati area. We were part of MAG IAS, which was a multinational industrial automation company, and we saw further growth into this kind of a product, and we became a standalone company in 2013. So the product that we deliver to our customer is called Freedom, all right? And so it is a smart manufacturing platform where we connect all of the equipment, any kind of an asset, any kind of a manufacturing asset, and we digitize it, and then we provide analytics from a web-based type of platform. We like to think that we can connect just about any kind of asset from the shop floor and then provide reports to any role in the company. We serve a lot of discrete manufacturing, which you can see on the screen in some of our key segments. And our group is a little bit different in that we have a ton of experience in manufacturing IT solutions, but we also have a lot of operating technologies. So we've run our own factories. We've had all kinds of roles in continuous improvement and operations, manufacturing, over 200 years, as a matter of fact. And so we think we have a unique perspective of being able to connect the IT world to the OT world. So today, what I'd like to talk to you about is a little bit about the advancements in digital manufacturing. As you know, there's a ton of buzzwords out there. There's a lot of jargon, all that sort of thing. And so I'm going to go through a little bit of that and then kind of show you a little bit of the advancements. And we'll probably talk a little bit about some impediments potentially and maybe ways to overcome. So first to start off with is, what is digital manufacturing? All right, so it's really technology that links all your systems and all your processes from the start to the end of all the areas of production with an integrated approach, which is really like what we're going to talk about a little bit about digital thread from manufacturing, from design to production and on to servicing of final products. What is the Industry 4.0? You've heard people talk about that. You've heard people talk about the industrial Internet of Things, and I like them that they're fairly similar. So Industry 4.0 is termed the fourth industrial revolution, and it's fusing of all the things we learned from the other three. So from mechanization, mass production, and then the introduction of computers and technology in the 70s to now where we're integrating not only the physical but to the digital and even the biological worlds is what is deemed as the fourth revolution. Now that phrase was from my understanding is that, and my experience was termed a lot in Germany and in Europe. All right, and when we tend to call that Industry 4.0 in this country, but we also tend to call it the industrial Internet of Things as well. And so very similar to the fourth industrial revolution, it's really a convergence of OT type technologies and IT type technologies. So we're getting smarter and smarter assets out there that can sense. They have tons of sensors. They can communicate externally. They can store information, even in very small devices that are connected to some of these machines, or the machines themselves can store that information. And all of that can be culminated to provide real-time analytics applications. They can consume and transform data into something actionable. So something that people can take action to try to improve the process. Some of the benefits. All right, so since this is a field that we play actively in, is that our goal is to help our customers increase their production margins and profits. And so how do you do that? Is that oftentimes is that it's through efficiencies. It's through productivity improvements from being able, to run that equipment a little more efficiently, a little more often. You have increased output. And so a lot of this is that when some of this happens is that you get a lot of other side benefits. So if you can turn your inventory more often, then you need less inventory, right? So, and all that's helpful is that if you can be more nimble and you can react to your demands quickly and productively. Okay, so the current state of digital manufacturing is that I'm going to talk a little bit about both some advancements and some challenges. And so we're going to cover a lot of these topics, and then we'll get to some challenges, and then we'll have just a few minutes to talk about some ways to overcome and move forward. So let's talk a little bit about digital twin and digital thread. For me personally, is that these were sometimes very nebulous, sort of confusing kind of terms about what that means. So you hear a lot of people that throw the word digital twin out there, all right? And what that really means is that I've got a virtual environment that sort of mimics the physical environment. So in the past, so that you could actually create and build and even test some products virtually before you're out there doing it physically, or you could do it in tandem and you could do some problem solving, all right? And so people are really focused on digital twins. And I would say is that today is that there are elements of that, or maybe even islands of automation, that fall into digital twins. Some examples of that are like CAD models. All right, so you have a CAD model of the part, right, of which then you can actually have a pretty good idea and visualize what that product's going to look like when you're done manufacturing it. So you can even take that information even further, and then you can use an integrated CAM model that you can actually then generate a G-code program. But a lot of these systems are still, they're integrated, but they're still fairly separate. And if you wanted to actually review about how that manufacturing would take place, is that you might have something in the CAM model that could allow you to do some simulation to look at toolpath. But if you wanted to really look at it holistically and really model it off the G code that you created, then you could use programs like Vericut or things like that to actually look at it even further. So these are some examples of digital twins. where I see it going further is that a lot of the control system providers like Siemens, like Fanuc, is that they now offer things like virtual NCKs, which means that you can actually run the control and run your program on this control, and you can actually start to get some feedback on how this will act virtually. All right, so all of this is morphing and developing even further to where you'll be able to go from art to part, and be able to virtualize that all the way through, which is a little bit about what digital thread is about. So you have a communication framework with an integrated view that you can see the product flow all the way from the beginning to the end, from the design until you see that product working out in the field. And so a lot of those same topics I was talking about is that you say, how do I take it from just an artist rendering through the whole design process, working that through tool management, logistics, through your ERP, and through now monitoring and providing real-time feedback on how the machining or the manufacturing process is going, along with some quality control. So it's really about how do I digitize it all the way through from the beginning to the end, and that's digital thread. Okay, so let's talk a little bit about some of IIoT and machine monitoring and the advancements in that area. So we participate in IIoT ourselves. I mean, that is our main business. So it's IIoT and machine monitoring. We've been doing that for quite a while. When it comes to IoT, is that we're really converging operational technologies and informational technologies. And you can get a lot of this technology can be deployed both on-premise, or you can deploy it out into the cloud. And it's really about real-time analytics, about applications, and it's a lot of it has started off with OEE. So is that how efficiently are you running the equipment, and when you're running it, are you running at rate, and what's the yield out of all of these processes? That's how all of this began with machine monitoring, was a large focus on OEE. All right. It is now moved on to more than that, right? So now add a little more of the IIoT technology, which is more sensor-based, is that a lot of this equipment already has a wide variety of sensors, but you can also now inexpensively deploy even more sensors to processes. And those sensors can do, instead of just on and off type of data, like is the machine running or is it not running, is that you can now look at analog type data. So like temperatures, currents, pressures, even fluid chemistry. So you can now look at concentrations of coolant. You can look at conductivity, pH, all that sort of thing is now available. And it will tell you a lot about the health of your machine, but it can also tell you a lot about the health of your process. So I'm going to throw up a dashboard here just to give an example. Okay, so this is a dashboard. And it actually comes from some of our software applications. And so there's a lot going on with this dashboard. All right, so let's just talk about a little bit about the sensor technology. So what you see here is that this is the deviation from nominal of a diameter. All right, and so 0 would be perfect, and this is, when we're deviating it up to about, let's just say 12 tenths, as high as here. And so this had a closed loop feedback. So you can see is that the process would correct itself, and then it would drift, and then it would correct itself. So each one of these is happening at about a 10-second clip. And so we're actually getting some measurements, on the quality of the process. We turn right back around and we have some performance related OEE type of data, to where the availability here would say is that this particular machine is that it is running or adding value 86% of the time within the time frame we specified. And when it is running, is that 71% of the time is that it is running at the right rate or the right velocity, right cycle time. And and we have about a 92% yield. And then when you multiply all those together, then you get about a 57% OEE. And we collect all of that in real time, along with some of this process related data. And then over here is that we have some more information about cycle time. So we can look to see if this is our expected cycle time of 10 seconds. is that we can see how well are we achieving it from part to part. And you can get analytics here that would show you for this particular part, how many we've made, what's our average cycle times. You can also understand how many parts we're making per hour versus a goal and see what your part variance is. So there is a lot going on in real time, but you can see is that you can look at it at a glance and you can glean quite a bit about this process. Okay, so moving on is that now that you have some of this data, is that you have some analog data, you have some digital data, and that sort of thing, is that you can start to apply techniques like condition-based monitoring and machine learning. So condition-based monitoring has been around for a little while, all right? And so I would say is that it's not necessarily new. I would say that it probably is coming into its own because it's now easier to get the data that you want and then apply rules. And that's what condition-based monitoring is about. It is about rules for thresholds or averages or trends or things of that nature. And the use cases here, the one that's really obvious is maybe runtime maintenance. So you could say, after I have this many spindle hours, just like an hour meter on your machine, then I need to do some maintenance. You could also look at other wear components, excuse me, such as how many tool changes did I do, and how many, ball screw paths did I take, or what's my spindle load, or something like that. All right, and so then you can do some runtime maintenance. Machine health, I mentioned spindle load. So how often am I putting this spindle under duress? What kinds of vibrations am I seeing? And so here is that you could keep the machine itself will probably has that on board that says it'll keep itself from destroying itself or causing harm. But then you can also record that, and you can get text messages and all kinds of things here that says when these conditions happen, I'd like to know about it. For process health, there is existing technology that continues to grow when it comes to things like adaptive control. So this is your closed loop feedback that says I can change speeds, feeds, and so on based on the feedback that I'm getting on spindle load and vibrations and other things. I can detect whether I've had a collision through different sensors. I can also detect when I have different types of tool wear. So machine learning, though, is that it is probably the most emerging technology that's out there. So this is a part of artificial intelligence, and this is focused on using complex algorithms within an application that will then improve their accuracy over time. So they learn based on the type of algorithm that they are. And there's really three kinds, right? There's supervised learning, unsupervised learning, and reinforcement learning. So supervised learning is probably the most common today. All right, so supervised learning says, I'm going to throw a lot of inputs at this model. So spindle load is always a good one. You could also have temperatures, you could have cycles, you could have alarms, that sort of thing. And that you're actually then saying, I've got a set of outputs of what I'm trying to predict. I'm trying to predict a spindle failure or a component failure. All right, and so how will these inputs and with algorithms I put it will affect these outputs? The unsupervised learning, I think, is a little more difficult because you're not trying to lead the witness, if you will, is that you're putting all these inputs and then you're trying to get this model to use algorithms to actually look at data that you may have thought might be unrelated, all right, and that might be able to give you some information about that process or about that asset that would be helpful, and the obvious application for a lot of this is predictive maintenance. Everybody wants to get to predictive maintenance or predictive tool life or predictive anything, when it comes to manufacturing. So when it comes to this type of technology, is that I can show you something, fairly simple when it comes to not only condition-based, but maybe a little bit of machine learning here. So in this case, this is a rules engine, that is also part of our software. And so here we can specify for a certain machine and a time frame is that what we're looking at here is like we'd like to see the slope of the trend line of the length of this cycle time. So when we're producing this part, and we're going to just keep looking at that on a rolling 8 hours. So, your input data is constantly changing, but we're always looking at this particular program and how long it takes to make it, and if that is going up or down by just looking at the trend line. And so, what this rule will tell you is that if that trend is increasing, then it's going to send an email to me, that says that, our cycle times are growing. And you could apply this, as you can imagine, to quality is probably the one that comes to mind the most, is that if I'm deviating from nominal and that is growing over time, then it would make sense, that we stop or go investigate. And you can get this automated so that you don't have to, be there constantly measuring all the time. Excuse me. Other advancements in digital technologies is that mobile technology is everywhere. Everybody's got a cell phone, and we see more and more tablets out in the manufacturing workspace, is that they've become easier and more cost effective, and they're very familiar with everybody. People know how to use them, but they're very portable and efficient, right? And like I said, the cost has come down dramatically. I think some of the challenges that you have with this type of technology is you still have all the connectivity piece. So you still have, all the security challenges. You still have the Wi-Fi networks that you have to manage and where you can access with it and make it easy to do, make it easy to access. And probably one of the other challenges is how do you manage all those tablets? They're portable, but that means that you've got to have your arms around it, and you have to be able to understand what's deployed to them. And so there's endpoint management software that's out there, and I think it's becoming more and more relevant, as people are trying to get their arms around this mobile technology. And so it's not, it was, I would say, easier when you had PCs sitting on the floor, that didn't move around, so the fact that they're mobile and you're trying to manage this whole fleet of tablets or mobile devices that's really the challenge. But it is really handy for things like machine monitoring and real-time KPIs. So if you think about some of the things we just talked about, I can get text messages and email reports about how things are running out on the shop floor as I'm walking around or I'm in meetings. Okay, so another advancement is that it's the use of distributed computing resources and just connectivity in general. All right, so what I'm showing here is an example of an IIoT architecture. All right, so there's all kinds of different ways to do this. This is probably one of the more simple ones. And so we're, in this case, is that we're making use of different kinds of computing resources located in different places. All right, so first off, let's start with ones that you're probably familiar with, right? So cloud hosting is one that we're familiar with. Probably the two big players out in the market is Amazon and Microsoft. We have some experience with Amazon, and I would say is that they have made this very cost effective for you to and easy to deploy applications to the cloud. So, you can see different kinds of computing resources as a service. Then you can get different kinds of applications such as ERP, machine monitoring. There's all, everything that you can do now, you could probably get in a cloud computing resource. The question is whether you should or not, right? And that has to do with some of the, some of the security issues, all right? And so if you're not going to use it in a public cloud externally, is that VMware and Hyper-V are virtual environments that have really gained a lot of popularity in recent years to where you can do this on premise. So you can have virtual machines using that type of technology. You can even do a hybrid cloud where you've got a combination of both public and private. All right, so it's all about it's fast, it's scalable, it's secure, and it's really low cost computing is really what cloud hosting is about. Now, when it comes to fog or the periphery, is that when you're communicating like in a machine monitoring environment, is that the one thing you don't want is that you don't want all these machines or all these assets that go straight out to the cloud, right? That's not recommended. It's not secure. All right, so you usually have some sort of fog node that's there locally that says this is where everything goes, and then this particular resource will post things to the cloud. All right, so all your real-time machine interfaces and all that sort of thing will live here. Data warehouses can live here. Your data lakes. There's other types of things that can communicate to the cloud. So in this case, is that we would have all these machines report here first, and then this one device or this one server then can post that out to the cloud securely. Then we get into edge computing. So edge computing is really what's on the industrial controllers, and some of these are directly on the machines themselves, and some of those will require a hardware appliance just because of the age of the equipment. But there's something for everyone here. All right, and so a lot of this will depend on the OEM, or will provide a lot of this kind of applications to mine data out of these devices. So what kind of data can you get? All right, so if you look at the different kinds of data, is that you have some basic data that can be provided by simple hardware devices. You have software interfaces that can reside on this machine control that can give you more data, and then you can deploy your own sensors. All right, if what you're getting here is not provided by the OEM, then you can deploy some sensors yourself. All right, and you can get even more data. There are different kinds of standards when it comes to how machines or these devices communicate to the cloud or to other applications. All right, and there's probably the two prevalent protocols right now is MT Connect. So MT Connect was established by the Association for Manufacturing Technology in 2008, and their whole goal was to provide a standard of how machines or manufacturing assets communicate externally to other applications. So you have a very complex data dictionary that says that when the machine's in cycle, I know that it's this data item. It will always represent whether it's in cycle or not. So it's a really nice standard that a lot of work has been done. OPC is very prevalent in the PLC world and other worlds as well. Is that it too can provide a standard, but it really provides you a really nice mechanism for you to connect and actually get information from different types of devices. And these are the two that you'll want to look for when you're establishing your architecture. Okay, so let's talk a little bit about some challenges. So the one that probably comes to everybody's minds is security, right? So there's lots of cyber attacks that are in the news every single day. There's ransomware, there's all this sort of thing. You have to think about machines that you're suddenly going to plug an Ethernet cord into, right? And so you have to have some concerns about viruses on your assets. You have to think about that you really don't want these things out on the internet themselves. And a lot of these machines is that you don't want them to automatically update maybe their Windows environment automatically. So there are some things to think about, all right? Cloud computing concerns is that my data now lives out in the cloud, right? And what kind of concerns should I have in that regards, and what is the mechanism? Is it encrypted on how I get that data out there? The good news is that there's a solution for all of that, right? And you saw a little bit of that, just even in the architecture that I presented prior. And a lot of that is in place already in a lot of factories today. So the good news is that I don't think that it's a showstopper, right? And so I think that more and more companies are feeling more comfortable with the cloud. Now, I will say is that the manufacturing community has probably been, I would say, the most conservative bunch of people that are moving to the cloud, right? But it's getting there. We're seeing more and more cloud deployments ourselves. The second thing is that you have adoption and culture. So I read an interesting article not too long ago from Deloitte, and that says that 49% of U.S. manufacturing still depend on pen and paper. And in fact, a good bit of those are still saying that they're going to continue in that way. All right. And so I think adoption, and I think that a lot of that is workforce related. And I think a lot of that will change over the next few years, especially as more and more of the baby boomers are starting to move into retirement. And so I think that the comfort level of moving it more and more into the digital age, I think will happen. But for sure is that it has been slow. Even though there's a ton of technology out there, the adoption, has not followed completely. I think there's also maybe some trust of whether the information I'm getting is correct, whether there's a fear of, am I getting false positives or false negatives when it comes to all of that. And then there's a perception with cost and ROI. So there's a preference to buy more capacity versus deploying something that's cost effective and working on continuous improvement. And so, could I get twice as much out of my existing assets versus just going out and buying another one? And I think it is that is also starting to change as well. I think also is that some of the challenges that we run into when you're actually implementing is that it's not really treated as a continuous improvement project. Is that it's looked for advanced reporting, all right, and so it doesn't have a really great limit or defined scope, and that we're often asked that, what's your use case? And they say just collect everything, all right, and which is not exactly the right approach. And finally is that just knowledge and skills, which we touched on earlier, just about people that it's complex enough that they can be able to install it, support it, and understand it. Okay, so how to overcome? So I think to all of that I just mentioned is that it is really cost effective for an IIoT type of deployment. So I would say is that a 3% improvement in your performance will typically pay for this kind of an investment in a few months. So a lot of times is that you can actually treat it as a continuous improvement project, launch it with some fanfare, and you will see great returns in a short amount of time. It's pretty easy to deploy, pretty easy to use. So a lot of this network infrastructure that I touched on earlier is that it exists already. And so it's just a matter of plugging into what is there and just fleshing it out a little bit further. So it's not one of these projects that's going to linger for months and months and months. Is that it's getting better and better to where you can deploy this in days or weeks. We typically see usually at least a 10% productivity improvement just even in the first month that it's deployed. And that usually represents a pretty dramatic increase in product margins and inventory turns. As far as adoption, is that anybody with a continuous improvement mind is that this is a great tool. It is actually a companion tool for lean and agile continuous improvement. So back quite a few years ago when lean manufacturing started, is that everybody was doing this with pen and paper and just observation. So you can really jumpstart lean with tools such as what we've talked about in this presentation. It's real time, it's accurate. You get rid of a lot of other waste streams of just trying to track this in labor intensive paper type systems. It gives you really timely feedback. It's immediate. You've got history. And quite honestly is that you can give the shop a voice. All right. So it really unemotionally highlights process and machine reliability type challenges. All right. So it's really all about transparency. You can get to root cause pretty quickly, and it will really provide some benefits. Okay, some strategies. So I think begin with the end in mind, but just get started. One of the biggest challenges to any kind of project is just launching, right? So clearly define your problem and how you want to measure success. So I mean, you just got to put it into SMART goals. So you'd say, I'd like to double my inventory turns in 6 months. I'd like to cut my cycle time in half. I'd like to double the output of these critical assets. So I think you can put it in very operational terms that then you can drive into some informational specifics. So you can identify where those pain points are in those use cases. Take a minute to assess the culture. Is your culture continuous improvement or status quo? Look for those champions that are continuous improvement minded, and select an operational champion. So, it's not really an IT project. Make it operational, and then use IT people to help drive it. Figure out where your limitation constraints, maybe your investment, your return on investment. At least know what that is financially, of course. Assess what kind of equipment will need to be connected. What's your critical assets, and what kind of data are you looking for? And then just look for quick wins. So if you can, get to the bottom of one issue and you can dramatically improve upon it, it really helps the culture, helps them move forward. It helps you to gain some a groundswell. Keep it really simple. Start off slow, scale it, and then grow based on your needs. And then use experienced manufacturing IT and OT solutions provider. They can help you. I mean, each company has to do it themselves, but they can also use other providers, that can help them do it. So, I hope that you got some benefit out of today's discussion on advancements in digital manufacturing. Is that feel free to visit our website, or feel free to drop either one of us emails or ask us any questions. We'd be happy to answer them and work with you and your team.
Thank you very much, Jeff. Appreciate it. That does wrap up today's event. We want to remind everyone that if you'd like to view any of our previous web events, that they can be found in the About section of our website, freedomiot.com. Additionally, if you're interested in learning more about the Freedom software, would like to see a live demo, or interested in a no-risk trial on your own equipment, again, please reach out to our team. We're ready, willing, and available to connect with your team so that we can discuss more options. Thank you again. We hope that everyone has a safe and productive rest of the week, and we'll talk to you again soon. Have a great week. Thank you.
Thank you very much, everyone.